Hello again, everybody. So now that I have done this assembly and put everything together, I wanted to kind of have a post-mortem, I guess you'd call it, on having built it. So I wrote down along the way some of the reflections that I'd had and some of the tools that I had and needed and would recommend if anybody else were to build this, and some of the challenges that I faced and things that I wished I'd known up front when I built it, and things that I will probably bring, knowledge that I've gained that I'll bring to the next build that I'll do, or the next repair project, or whatever I decide to do with building radios. So, biggest first thing, a lot of this what I have written down here is just recommended materials and tools that made this job a lot easier, like a lot easier. The first one is having a jeweler's loupe, or some sort of magnifying glass that you can zoom in and look at the board. You need something that you can look in there and see what you're looking at, because the holes are extremely tiny on this board, and probably the other boards in this series too. The letters are extremely tiny, the wires are tiny, the solder joints are tiny, everything is tiny on this project, and I used that loupe to see what I was doing and to analyze, how well of a job I'd just done soldering constantly. Every joint pretty much, I had to look at it with that loupe. Even though I've got very good eyesight, I still needed the loupe to see what was going on. I don't think I could have done this project without it. The next one is having really good lighting, whether that's, I've used a headlamp a lot, just because it was handy and it's what I had and it works well. Some sort of an overhead light, like what I've got on now, would work okay, but even that, I don't think that would be bright enough. I really needed a good pure white light shining down on the project so I could read everything and see everything and kind of deal with all the little shadows and stuff, good lighting. Another thing that I had that was really useful for this project, they call them a precision flush cut. They look like any other kind of side cutters, but they're not like a side cutters like you'd buy for fencing or something like that. They're not big like that. Obviously, these are little bitty, designed for cutting electronics. Basically, designed just for this task. By some luck, I had one around. I don't know where I got it. I don't remember where I got it from. It was a relatively inexpensive one. I literally wore it out doing this. By the end, it was destroyed. I mean, I cut that many little pieces of wire, hundreds of little solder joints it must have been on this little board when I made it. So having a good flush cutting pliers is really important. Another thing that I was glad I had around, I had some just normal, clear, untinted safety glasses. I'm big on that anyway. I try to really protect my eyes and my hearing and my hands and things like that. But safety glasses, because when you're clipping those little bitty clippings off, they're going everywhere. Despite best efforts, I would hold on to them with the tweezers and then clip them. That worked okay, but occasionally they were only about a millimeter or so long, and when you clip them, they'd fly. That is something you do not want in your eye. That'd probably be a trip to the eye doctor to get something dug out of your eye. That would not be good. Also, when you're winding the toroids, that wire going around and around and around. It's small gauge wire, poke you. I mean, I didn't feel very safe without the safety glasses, all things considered. So a lot of the times for the cutting and the wrapping of the toroids and that, I was wearing safety glasses. I didn't find that splattering from the soldering iron was a big deal. I haven't had a whole lot of practice soldering things. I initially thought that was going to be an issue, maybe, because you're right up here looking at things while you're soldering it. I didn't have any problems there. I did notice occasionally that there would be the little bit of flux and stuff would splatter, but it wasn't too bad. That is the other thing, is having flux. So my little flux kit came with a little brush like this that I could get in there and kind of put the flux on. So it's kind of big paste flux. I've seen some of the electronics people on YouTube that they have flux in a little syringe that they can just get in there and just dab it on. That looked really nice. I didn't have that. I don't know where they get that, but that would be probably a lot easier than using a brush and all that. Probably be a lot less cleanup too, because you get it targeted right on the joint where you want it, and then you can just solder it. But I do think the flux was important. Some of those joints you could just barely get on top of with the soldering tip. Also having a small enough soldering tip to get into all those little places, because you don't want to touch the other components that already happen to be soldered to the board. whatever they were, resistors and things like that. You just want to heat the joint where you're trying to solder, get on, get off, and let it cool. So, what else? Another big thing, a multimeter. So, I happen to have I think it's a Klein multimeter. It's more for like stuff around the house and things like that. It's like what an electrician would use. It's not really designed for electronics, but it worked fine. So yeah, having that. Sorry about that. Anyway, yeah, multimeter for continuity was really important, particularly with the toroids, because those toroids are ceramically coated to avoid the toroid like rounding out or touching itself and messing up the circuit. And so when you go to solder the toroid in, you have these little bitty tiny wires, but they have this clear ceramic coating on the outside of them that you have to burn away or somehow get off. Yeah, I've seen a couple people, they were using an X-Acto knife and stripping the coating off with an X-Acto knife and trusting that. I wanted to switch methods. I did try briefly using some sandpaper because I thought that surely would get it off. And believe it or not, it didn't seem to want to come off with just sandpaper. I guess I wasn't sanding enough. I didn't want to take too much. I didn't want to have some kind of other unexpected issue from sanding it too much, and making the little bitty wires too small. I thought maybe that could be an issue. I don't think it would have been, but I wasn't for sure, so I was erring on the side of caution. So I tried to stick to his guide as much as possible, and he recommended just trying to burn it off. I tried a couple different variations of that and ended up basically just settling on, installing the toroid in the slots where it goes, and then just soldering it a little bit longer. And it did eventually burn off. I found that I had to tick up my soldering iron a little bit hotter than what I was for the rest of the joints to get it done, and having to dwell on it just a little bit. But you could kind of tell when it was, when it had finished cooking off. But that multimeter was really key to determining for sure that there was continuity between the different inductors. So that's why I said the digital multimeter was really important. I don't think I really needed it for anything else, but I think there would have been a lot more guess and check if those toroids hadn't made connections like they were supposed to. I know he specifically mentioned in the guide that if the toroids didn't make the right kind of connections, it probably wouldn't even power on. So he said that was an issue for a lot of trouble for people. So I would recommend having the multimeter for continuity and checking along the way to make sure that you have good continuity between the different joints on the inductors, particularly the big one, because it had 3 or 4 points where it had to make a circuit. So another thing was having good files. I happened to have, I don't know how I had it, but I had a little file laying around the house that had almost like a diamond coating on it. And that seemed to work really well for filing the rough edges off the circuit board, particularly on that one board where the other smaller boards had to be popped out of it. Left a really, really rough, nasty edge where it pops loose. And I probably wouldn't go together if you left that on there, at least in this case. Maybe in the bigger form factor it would fit, but not in this little bitty one. So having a file that you could file down those edges and make the board fit was really, really important. I also had really good luck with that Loctite fixative gum. You can get it at your local big box store. Most likely it's used for like hanging pictures on the wall and sticking things down that you don't want to move, things like that. I think they actually call it fixative gum or some sort of gum, but it's just sticky, tacky. It's thicker than chewing gum. I wouldn't use chewing gum, but it's on the order of that. It's almost like clay. And I used 2 small to large pieces of that to kind of hold things in place while I was soldering it. And I thought that was a lot more useful than a helping hands or something like that I just didn't have very good luck with. I don't think a helping hands, or at least the one I have, my inexpensive one, would have done a good enough job. And getting everything located and put into place correctly was a challenge as it was, and I still ended up having some small issues, but I don't think anything that's going to be a showstopper. But positioning the pieces was critical, and just eyeballing it and hoping for the best is not going to cut it for this project, at least. high proof alcohol, isopropyl 90% or something like that would be good for this. I ended up only having 70%, which really wasn't the right strength for this. I didn't want to have to go to the store to get more, particularly on a holiday. Also, little brushes. I doubled up and ended up using this one in a lot of the cases to brush away the goo from the solder, the residue from that, which I guess you're not supposed to leave on your circuitry. So getting that off. Also, some of the Q-tips, from like the pharmacy, that was useful. And then I also ended up using that gum because the Q-tips tend to leave behind like little bitty fuzz that you can see. You're only going to see it with your little loop, your jeweler's loop, but you can see fuzz that's left behind. So I ended up using some of that fixative putty to kind of pull that off, kind of like a lint roller. I used the calipers a little bit just to make doubly sure that I had the right toroids and things like that selected. I know they were color coded, and I don't think there was any way to mix them up, but it wasn't very specific in the guide, and so I ended up Googling for sure what kind of toroid I was grabbing for, just so I was sure of what I was doing. And I used calipers to measure it and make sure. Tweezers were important. I have a little precision screwdriver set that came with the tweezers that's kind of bent at an angle. That was the one that's the one I'm used to using too. It's a tweezers, instead of being a straight tip tweezers, it's got a little bit of a bend at the end of it, and then it opens here at the end. That was really useful. Also the precision screwdriver out of that. They were standard Phillips screws, but being small, relatively small, a good screwdriver that's sized appropriately was good. Then the other thing is just like the time and the patience, and also a highlighter and a pen. And I checked off, step by step as I went through the guide, so I didn't get lost, or in case I had to stop this and come back to it later, not knowing how much later I'd have to come back and work on it. I went ahead and highlighted in the guide. This is for the band of radio that I've bought, so that I didn't get confused, particularly with like wrapping the toroids and stuff like that, making sure that I was doing it, that I was following the guide correctly, basically. That was important. And I think that's it as far as the tools. Let me see if I've forgotten anything or haven't mentioned anything. Making sure the toroids are wrapped tightly, but not pulling it so tight that the wire breaks. I did have one instance where I pulled the wire a little bit too tightly to the toroid and ended up snapping it. So I think it was less about like having really strong tension on the wire when you have to have some tension, but it was more about like making sure that it followed the edge of the toroid around, because even though it was small gauge wire, it didn't want to hug the sides of the toroid quite right in a lot of the cases, and it didn't look bad until you looked at it in the loop. Again, why the loop was important, or at least a phone camera or some way that you can zoom in and actually see something. Using the phone camera in particular, or some sort of camera with a good zoom, was made counting those little bitty toroids a lot easier, because it was small enough that even with the loop and even like with a loop and a hat pin or the tweezers, it was still hard to zoom in and see for sure if I had wrapped enough. It was that small. What else? Saving all the scraps, all the little clippings and whatnot off your resistors and capacitors and that kind of stuff. Save it all, because you will end up using it later. And almost all of it. Like, there is very little waste in this kit. It's pretty much exactly what you need, and there's not much room for error either. I think if I was going to build another one of these in the future, or if I was going to build the same one or a similar one, I think I would probably insert and position a lot of the similar components. When it's doing the capacitors and things like that, I'd probably put a bunch of them in and then flip it over and solder them all. But probably for the first time around, it was better to go step by step and just install them 2, 3 at a time, 4 at a time, whatever, and then solder, stop, read. But now that I've got a little bit of experience under my belt, I feel like I could probably handle just putting them in and soldering it down. Making sure to orient them consistently. He tells you in the guide that there's basically like a unspoken rule or an unspoken standard of like, all the little components have markings and identification on them. They'll say like C24, T52, or whatever the markings on them are. And basically the idea is like you orient them either facing, however you orient the circuit you're soldering on, whether it's oriented forward or backward, just keep it consistent. And then when you insert the components, you insert them in such a way that the writing is facing either forward or to the right, and you follow that while you're putting them in, so that it's easy when you're inspecting it with your loop and whatnot to make sure that you've inserted the right components where they're supposed to be. You don't have to continuously rotate the board and try to figure out where the writing is, because you've done all that work up front to make sure that it was consistent and easy to read what you'd done, just as a means of checking your work, because you probably will have to. And the only exception to that is like if two of them are like right up next to each other and you have to orient one the other way so that you can read this one on this side and this one on that side. For readability, you can break that rule, but in general, try to keep your orientation consistent for inspection purposes. The other scary thing, the power connector and the Schottky diode are ended up being very, very, very close together, and I thought that I'd maybe made a power solder bridge between the two of them, but again, if you zoom in with the loop, you could see that no, there actually was a gap. And my understanding of low voltage stuff is that low voltage doesn't tend to jump gaps, so it should be fine as long as they're not physically touching. But yeah, that's just how it's designed. I mean, they're just that close. Same type of deal with the little audio input connectors. Like when you solder those down, the pads for the different pieces or the different contacts that map inside the little audio jacks are just maybe 0.5 millimeter from each other. I mean, they're very close together. So, I mean, it would be incredibly easy for just a little bit of solder to bloop over the edge and connect them. I don't know. I'm assuming that would be bad, but they're sitting right next to each other. Yeah. Also, I think just like taking a lot of time to break the boards apart. Those couple of boards there were literally stuffed together so tight. And there was like little bitty delicate bridges on the board that it would have broken really easy, I think, if I'd have done that part quickly. So I might do that first next time, just so that the boards are separated and sanded and everything ahead of time, to where if something does happen and they break or whatever, at least I've got new on the way while I'm building the rest of it. Also, where that automatic gain correction board goes, I feel like that was, the way the guide reads, that was kind of an afterthought, and there wasn't really room for it, but they made room for it anyway. And it ends up being just right on top of that one capacitor, which I showed in one of the short videos. But making sure that it has room to sit in there correctly, so I don't have to offset it off the top of the board, which probably isn't ideal, but I think it'll be fine. Yeah, making sure that all fits, but I don't feel like that was really my fault. I mean, that was kind of an accident. I didn't realize. I got to the end of the guide and then realized that the actual installation of that little board was in a separate manual. So now I know. But I think that's about it. I guess, yeah, also making sure that you have the other equipment that you need to test this thing. I was kind of under the impression that once I was done building it, I would be able just to turn it on and calibrate it and all that. But according to the guide, at least, you're supposed to have a dummy load of some sort or whatever connected to it, so you don't, harm the radio while it does its test procedure. So, in my case, I'm still learning all this stuff, so I don't have the dummy load and the, RF cable and stuff to hook up to this thing to get it to work. So I'm a little bit handicapped there. I need to do some ordering and get a couple things here, so I can build my antenna and start transmitting. I've already got the CW key and all that, but yeah, some of this other stuff I don't have. So I need to get that ordered, need to get it here, and then I can actually, I guess, get on the air. But that's pretty much what I've got. It was a lot of fun building it. I really enjoyed building it. I want to do another one, and I want to find other kits that are similar to this. I thought it was a lot of fun. I hope it actually ends up transmitting and, gives me some entertainment value for a while. It looks like it's really well built. It looks like it should last quite a while. It's a little tank once it's put together. It's quite a nice little package, but so I guess we'll see. I don't know if I need to do the firmware or software updates on it. It says that you can if you have the right headers and the right connections and stuff. So I don't know if it's going to need it or not. It looks to me like it's probably on the right version of software, or it's probably not going to matter. So I probably won't mess with it. But if there's some reason to update it, I'll I'll do that and I'll upload that as well. So I guess the next thing that I upload will be, uh, calibrating and testing it, or I'll include that somewhere in the playlist or the videos. That's kind of what I've got for now. So thank you for watching. If you guys watched, and I don't know, feel free, I guess, to reach out or leave a comment or something if you guys have any questions, or if anybody ever watches this and gets any value out of it. Um, I realize the videos are not shot that well, but I guess I really wanted it more to be to show my progress in having built it, and just share my experience, whether anybody ever sees it or not. I didn't want to include a whole bunch of videos of the actual soldering process. I'm figuring that if anybody wants to assemble one of these, they know how that's all done. So why make a big long series and draw it out when I think really most people, they just need to see step to step to step and just have somebody else kind of walk them through it, or at least share an honest opinion of how it went, without a bunch of editing and grooming to make it look better than it was. I mean, this is pretty much how it went, and my honest experience. So I hope that helps anybody else that's out there, and best of luck if you guys decide to build one. Alpha India 5 Yankee Delta out. 73, guys.